In D, we're going to also need to eliminate by finding an LCM. So I can either change these both to 12s or change these both to 6s. Typically, I'd go with a smaller one, but let's do the one in front this time. So I will change these both to 12s, multiply by a 4, get 12x plus 8y equals 4. Multiply the second row by 3 and get, a negative 3, because I need to also get the opposite sign. So I'm going to then multiply by negative 3 and get negative 12x. Negative 9y is equal to positive 6. I'm going to add them, and these x's are going to eliminate, and I will get negative y is equal to 10. So y is equal to negative 10. Substitute back into one of the original problems. We'll go into the top one. So that's going to be 3x, and then 2 times a negative 10 is going to be a negative 20 is equal to 1. So then I have a minus 20, so I'm going to have to add 20 to both sides, and that will give me 3x is equal to 21. Then we'll divide both sides by the 3, and that will give us that x is 7. So we're going to have the ordered pair 7, negative 10. And we should check it, but I'm not going to at this minute. Remember, check back into the original. So for example, E, this time a little bit easier. I can easily change my 1 into a 2 by multiplying through, and I want the opposite sign, negative 2. So I'm going to keep my top row the same. I'm going to multiply my bottom row by negative 2. So negative 2x minus 6y equals minus 18. I'm going to add it. That eliminates, that eliminates. So I've got to have something here. So I have a 0 on the left side is equal to 0 on the right side. This is always true. So remember our solution, whenever it's always true for a system of equations, which solutions are always ordered pairs, is going to be an infinite number of solutions. So these graph to be the same line, so every single point on that line would be a solution. You can't say all real numbers because that's not true. It's an infinite number of solutions. Then F, that looks really nice, but I really can't eliminate anything quite yet because I get a negative 4 and a positive 10. So what I'm going to do is I just need to change the signs. So this is going to change and become a positive. This will be negative, and then it's equal to this will be negative. So be careful if you're going to do something like that. Make sure it's very clear. And then I'm going to add, this is going to become 0. 5 and negative 5 also is 0. So my left side is 0. But this time my right side, I get 7 and a negative 12, which is negative 5. And that is a false statement. It's never true. So this answer is going to be no solution. So you can write the 0 with a slash through it, or you could write no solution. A theater club sells a total of 101 tickets to its first play. A student ticket costs $1, an adult ticket costs $2.50. Total ticket sales are $164. How many student tickets were sold? So we always have those several unknowns, but we can set this up where it's dollars per tickets times tickets equals dollars, and set up problems as we did in the last unit. So here we got the student tickets. We have the adult tickets. Students are $1 and adult tickets are $2.50. We don't know how many tickets of each kind we have, so X and Y. Then we're going to multiply across to figure out how much we paid for those tickets. So $2.50 Y. They told us that their total number of tickets sold, the total number of tickets, which is are $164. Oh, we sold 101. So 101 tickets, and they cost $164. The equation is going to end up being here and here. we're going to have x plus y is equal to 101, and x plus 2.5y is equal to 164. We're going to use the elimination method to solve that, and I will let you do that. We'll finish it up in class.